In this lecture, I'll discuss the use of the least squares fit for estimation and prediction. So I mentioned previously that we can use this linear squares, this least squares fit, to try to find values for y at points that we didn't actually measure, for which there is no data. And those, if we look at points that are between already measured data points, that's called interpolation. If we're looking at values beyond them, that's of course extrapolation. Similar words there. So instead of averaging the data values and trying to say what would be next, we just run the line through there and take our value off the line. Now there's two common uses for this, and one is to predict a mean value. Actually, that has a little more accuracy associated with it, or to just say I'm going to try to predict a y value at a given value of x that is, as I said here, not necessarily associated with any data point. Now these are only estimates, so we're only going to know them up to a certain confidence, and we're using confidence intervals to build them. The student's t-distribution is used. I am simply giving you the formulas. If you can get your mind wrapped around these formulas and get some understanding of them, and also understand what those dashed lines on the graphs that you will see in journal articles or in other books discussing statistical studies, if you can understand that, that would be very good. Let's say you just want to predict the mean value of y that might occur at some value of x that you never measured. Okay, so there is a confidence interval about that. You say I want to predict that mean up to a certain confidence, and just like we've always done, alpha would be your error, 1 minus alpha is your confidence level that you are requiring. It could be 90%, 95.99, and from that you can determine a t-value is associated with that based on the degrees of freedom, and we take n minus 2 in this case instead of n minus 1. So take the size of the sample, subtract 2, and that's your degrees of freedom. From that you can find a t alpha. T alpha would be the value of t at the edge of the tails. The tails would have, added together, both tails would have a total area of alpha. Just regular confidence interval calculation. Alright, and here is the confidence interval for that value of x. Okay, so what we're looking at is what is the range of means of y at that value of x based on the least squares fit and what we know about the data. And let's look at the terms of this. As you see the terms, the rest of the equation makes sense. Okay, y hat p, that is the value on the line that you predicted from xp is going to be the value of x at which you wish to have data. This would be your p for prediction. Now y hat p means the value that you calculated. Okay, how did you find it? Y hat p, you knew your beta naught and your beta 1 for your equation, and you just put your value of x in here and got a y out. That gave you a point on the line. Then you are going to add and subtract because it's going to be a confidence interval about the line. Here's your t alpha that you know from your confidence intervals. You understand that. SE I'll describe in a minute. The square root of 1 over n plus the value of x minus the mean squared over the sum of the value of x minus the mean squared. Okay, not impossible terms. You might say, where did these come from? Again, this is an introductory class, and all you had to have was algebra here, so we're just going to stop with this and we're just going to let it be. I want you to have an idea of this and not be able to necessarily calculate it. That S with a subscript E is important. It is, and that's important for, whoops, I need the pen. S, that's lowercase s with an E. This is the standard deviation of the error, E for error. And we're going to see more of that in the next video. Okay, what is that? It's the sum of the SSE, sum of the squares of the errors, or sum of the squares of the residuals, divided by n minus 2. Oh, my word, math equation editor kind of messed up there. Here's what it is. Well, let me write it right. Data point minus the line squared, summing over all data points. Okay, take it, square it, add them up, and divide by n minus 2. And that gives me, obviously that's square, that's the variance. Take its square root, you get the standard deviation of the error. Now let's say you want to predict a particular y value, not just the mean. You can do that also, and it's the same situation. You're going to get a confidence interval of y's associated with this prediction at a particular value of x. So you have some xp, which is not necessarily measured. This is exactly the same from the previous slide. The 1 over n is the same, but there's a 1 sitting here. It's bigger. Okay, and now here's your predicted y value, standard deviation of the error, and your t alpha over 2. Let's see how these look, because this is something that you will see, and now I've shown you the formulas. Now I'll show you how it looks graphically. Here's what this result looks like on a graph, and you will see these in, like I said, in journal articles or in textbooks, wherever you're looking where someone's presenting statistical information. The solid line is your least squares fit. This is your linear regression here and here. Surrounding it are the dashed lines. The dashed lines show the limits of the 90% confidence interval for prediction of y and y mean, depending on what you'd have to read. There'd be a caption here explaining what was going on in the case. But these are showing the limits of a confidence interval, okay, at a certain confidence level, usually like 95% or 90%. Right. That means if I look, let's say at this point, which is not measured, okay, then the y values that I would, the confidence interval for the 95% confidence interval for y values, say that the y value that I'm predicting with 95% confidence would lie between those two values of y. Notice they usually have kind of a belted in region here near that point. So the whole point of this lecture is to show you that you can use this to predict, but you're not going to predict with certainty. You're going to predict with a certain confidence level. And there's what looks like complicated formulas, but I'm sure you could work your way through them. So these formulas that give you confidence limits based on the alpha that you choose, okay, or the 1 minus alpha confidence level that you want for prediction. So again, the predictions are an interval, not an exact number.